So today I'm going to talk about epilepsy. The disease is epilepsy. So guys, I'm going to keep it very short and precise. So it will be helpful for you also. So please, you should watch the whole video. So starting now, let's start. So firstly is epilepsy, seizures and convulsion. You should know the difference between three of these. These three are not the same. So epilepsy, basically you should know what is epilepsy. Epilepsy is a common neurological disorder. It is a disorder which is characterized by recurrent, recurrent episodes, that is known as seizures. Okay, so seizures, it occurs, and convulsion also, it leads to the body movement. Means seizure is what? It is an abnormal paroxysmal discharge that occurs at high frequency from the neurons. This is a seizure. And what talking about convulsion, it is an involuntary, spasmodic, violent. It occurred due to the contraction of the skeleton muscle. Okay, so guys, I think so I am clear about these three. It is a disorder. It is the abnormal discharge and it involves the involuntary movements. So this is the three definition. Now move to the next one. We move on to the next. So what can be the cause? Means epilepsy can be caused. It can be due to the genetic. It can be due to the primary or acquired neurological disorder. It can be due to the traumatic, or maybe it may be due to the idiopathic also. It can be due to the Alzheimer disease also. It can be due to the eclampsia also, and it can be epilepsy may be due to the many other drugs. It can be antiarrhythmic and many other drugs. So this is a cause. It can be various cause which leads to the seizure. Now we'll move on to the next, that is a classification of the seizure. So am I clear about these? So firstly we have done definition, next is the cause, and the third is about classification. So they are divided into two parts, that is a partial and generalized. Partial means that it is localized at a part of brain, and generalized means it involves whole part of the brain. In partial also there are many subtypes, that is simple, complex, and simple complex with secondary generalized. And generalized, it includes whole part of the brain. So in this also there are various subtypes, that is GTS, that is generalized tonic clonic, absence seizure, atonic, myoclonic, and infantile spasm. So these are the classification in short. Basically you should know what is depolarization and hyperpolarization. So as you can see, I have drawn the picture. So this is the nucleus. Okay, this is the diagram of a neuron. Okay, cell body, this is the nucleus. So basically when sodium charge, means sodium entry occurs, it leads to the depolarization. Okay, means positive charge come inside, so leads to the depolarization. When chloride, that is chloride is negatively charged, so when chloride ions come inside, it leads to the hyperpolarization. So guys, you should be very clear, if positive charge come inside, it leads to depolarization, and when negative charge come inside, it leads to the hyperpolarization. Means it leads to the activation, D, and hyperpolarization leads to the inactivation. Now we move to our next topic, that is pathogenesis, which is very important. So there are two neurotransmitters, that is excitatory and inhibitory. In excitatory, that's neurotransmitter is glutamate, and inhibitory, it is GABA. So basically why seizures occur? Seizures occur because the glutamate level increases, which leads to the seizure. So if we want to reduce the seizure, what we'll do, we'll decrease the glutamate level and increase the GABA level, which we can, after this we can resolve seizure. So let's talk about that. So guys, as I told you earlier, that when action potential starts, okay, so what happens, it leads to the entry of sodium ion and calcium ion. As I told you earlier, the positive charge when enter inside the neurons, so it leads to the depolarization. So further you can see depolarization occurs when calcium enters, it triggers the glutamate to release the vesicles from here, it releases in the synaptic cleft. Okay, so glutamate release in the synaptic left. Synaptic left is what? It is a space between the two neurons. So further glutamate bind to two types of receptor, that is AMPA and NMDA. AMP and NMDA. Further, one more entry occurs in the here, that is calcium channel. It occurs through the T-type channel. Here also you can see the calcium was entering. It was high voltage calcium channel, and here also the calcium influx is there through T-type calcium channel. So this is the excitatory neurotransmitter. Further, here also there are other inhibitory neurotransmitter, that is GABA. So GABA also bind to the GABA A receptors, and there is also one mechanism that occurs, that is reuptake mechanism. So guys, further, this is a further mechanism, this step occurs, this cycle occurs, which leads to the hyperexcitability and seizures occurs. When sodium enter inside, calcium enter inside to the sodium voltage gated channel and calcium gated channel, glutamate further releases into these vesicles into the synaptic cleft, which bind to the two receptor AMPA and NMDA. Further, what happened? It leads to the hyperexcitability and seizures occurs. So we need to resolve all this. We need to block this sodium, calcium, glutamate, NMDA receptor and reuptake mechanism, so that we can resolve the seizures. So guys, the drugs, pharmacotherapy of epilepsy will discuss in another lecture. I hope so you like this video.